Good evening, everyone. In today's class, we are going to start with the new chapter, Introduction to 3D Geometry. Before starting this chapter, I just want to refresh whatever we have studied in the earlier chapters about Cartesian plane. Cartesian plane is a two-dimensional coordinate plane formed by the intersection of two perpendicular lines. The horizontal line is known as the x-axis and the vertical line is known as the y-axis. This can be used to locate any point on a plane. So this is called a plane. If we have any location on the plane, we can easily use Cartesian coordinates to locate that point. For this, for example, this point can be represent any point on the Cartesian plane can be written as x comma y, where if I consider this point, it is going to be 5 comma 6. I can write this as 5 comma 6, meaning that on the x-axis it is 5 distance from the origin, and on the y-axis it is at the distance of 6 units. This is what it means. Now if we extend the same Cartesian plane, which is in 2D, to 3D, that is, here we have x-axis and y-axis. If we consider one more axis, then that is going to be called your rectangular coordinate axis. So I can define rectangular coordinate axis as if there are three lines which are mutually perpendicular to each other, meaning that x and y are perpendicular, y and z is perpendicular, also z and x are perpendicular, and they intersect at a point, and this point is called the origin. These three lines together are called rectangular coordinate axes. So any point on this space. So in 2D we talk about a plane. In 3D this is a space. So any point in space can be represented by x comma y comma z, where the first number, which is x, here I have taken an example of 3 comma 4 comma 5. What does this mean? It means that on the x-axis it is at the distance of 3 units from the origin. On the y-axis it is at the distance of 4 units from the origin, and in the z-axis it is at the distance of 5 units from the origin. This is what it means. Now any point on the x-axis, if I have to consider, then that point can be written as x comma 0 comma 0, right? Y-axis, any point on y-axis can be written as 0 comma y comma 0. Similarly, any point on z-axis can be written as 0 comma 0 comma z. We had the same thing in 2D or Cartesian plane also, right? Here we took any point on x-axis as x comma 0 and any point on y-axis as 0 comma 1. Similarly, in the 3D coordinate system, we take for x-axis, y-axis and z-axis also. The next part is called planes. I can tell that a coordinate system or rectangular coordinate axes are made up of three planes, namely xy plane, zy plane and zx plane. The blue one is xy plane, meaning that any point on this plane, if I have to consider, then the value of z is going to be 0, meaning that on the xy plane it is going to be x comma y comma 0. The coordinate of z axis in xy plane is going to be equal to 0. So I can tell coordinate which is 0. For xy plane, it is going to be the z coordinate, which is 0. For the yz plane, it is going to be x coordinate, which is 0. For zx plane, it is going to be the y coordinate, which is going to be equal to 0. So I can write any point on yz plane as 0 comma y comma z. Similarly, any point on the zx plane can be written as x comma 0 comma z. In 2D geometry, we had quadrants, right? We had our x-axis, y-axis, this was called the first quadrant, this was called the second quadrant, third quadrant, and fourth quadrant. Similar to our quadrants, we have octanes in three-dimensional geometry. What are your octanes? If the space is divided into 8 parts, this is the first part, which is having x, y, and z all are in positive. X, y, and z, if all are positive, it is called the first octant. Similarly, the second octant is going to be when the coordinate of x is negative, other two are positive. The third quadrant is where your x and y are negative, z is positive. Similarly, fourth, fifth, sixth, seventh, and eighth quadrant have been given in the table. Now, then you can have a question, how do you remember all this signs, right? Because you have how many signs? 8 into 3, 24 signs you have, right? So how can you remember this? To remember this, there is a pattern. Okay, what is that pattern? For x, okay, you can write 1 2 3 4 5 6 7 8, and for the x coordinate you can start by writing plus, then it is two negatives, two positives, two negatives, and a positive, right? So this is the pattern for x. You start with positive and end with positive. In the middle you put couple of negatives, couple of positives, couple of negatives again. This is how you are going to get the x axis for all the octants. Similarly, for y it is going to be plus plus, minus minus, plus plus, and minus minus. Similarly, for your z axis, it is going to be plus 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 plus, minus minus, minus minus. So you see a pattern here, right? So if you know this pattern, this table is very easy to learn. Let us move on to exercise 12.1, question number 1. Any a point is on x-axis, what are its y and z coordinates? If any point is on x-axis, then what is going to be the y and z coordinates? If any point is on x-axis, that point can be represented as x comma 0 comma 0. So what is going to be your y and z coordinate? I can tell y and z coordinate both are 0, right? Only x coordinate will exist, 0, y and z coordinate is going to be equal to 0. Moving on, the second question, a point is on xz plane, what can you say about its y coordinate? I know that if I have xz plane, that can be written as x comma 0 comma z, meaning that whenever I have xz plane, y is missing over here, meaning that y coordinate will be equal to 0. Or you can tell from here also x comma 0 comma z. So only x and y coordinate is going to exist in xz plane. So y is going to be equal to 0. The third one, name the octants in which the following points lie. Let me do one thing. Let me copy that table here. So I think it is going to be easy for you guys. Not this one. This one. Yes. Now, the first one, 1, comma 2, comma 3, it is going to lie in the which quadrant? This is going to lie in the first quadrant because all are positive. The second one, 4 comma minus 2 comma 3, this is plus minus plus. Where do we have plus minus plus? It is going to be the fourth quadrant, right? I hope you are getting it. So I will be writing here 1 comma 2 comma 3, this is the first one. So this is having, or this is lying in the first octant. Similarly, the second one is 4 comma minus 2 comma 3. So it is positive, negative, positive. It is in the fourth quadrant. Similarly, the third one 4 comma minus 2 comma minus 5. So it is positive, negative, and negative. So I can tell it is lying in the eighth quadrant. Similarly, you can solve for other points as well using this table. I'll move to the last question of this exercise. Fill in the blanks. The x-axis and y-axis together determine a plane known as, since x and y both are taken, it is known as your xy plane. The coordinates of points in xy plane are of the form x, comma y, comma 0. Coordinate planes divide the space into dash octants. We have 8 octants, right? So this completes our exercise 12.1. Let us move to next concept, which is distance between 2 points in space. This is similar to the distance between 2 points in a plane, right? If I have 2 points A and B lying in space, and the coordinates of A have been taken as x1, y1, z1, and the coordinates of B, if we have taken as x2, y2, and z2, then the distance between A and B, the point A and B, is given by x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. The only difference between the 2D one and the 3D one is the addition of one more axis, right? If I remove this, the formula is nothing but the distance between 2 points in a plane. If I add the z coordinate also, it is going to be the distance between 2 points in space. Let me consider problems based on the same concept. Exercise 12.2, question number 1. Find the distance between following pair of points. The points have been given as 2, 3, 5 and 4, 3, 1. So let us start the question by taking these points as A and B. So I can take, let A be x1, y1 and z1, and I will be taking that as 2, 3 and 5, 2 3 5, and let b be another point x2, y2 and z2, and let that point be 4 3 1. We have to find the distance between the following pair of points. I know that the distance formula, which is AB in space, it is given by root over x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Upon substituting the value of x2, x1, x2, y1, y2 and z1, z2, I will be getting 4 minus 2 whole square plus 3 minus 3 whole square plus 1 minus 5 whole square, right? You can either take x1 minus x2 or x2 minus x1. Both are one and the same, right? So you will be ending up with AB under the root 2 square. 4 minus 2 is 2, 2 square is 4 plus 3 minus 3 is 0, 0 square is 0, 1 minus 5 is minus 4, minus 4 whole square is 16. So 4 plus 0 plus 16, AB you will be getting as root 20. Root 20 can be further written as 20 you can divide with 2, 10, 2, 5, 5, 1. So you have a pair of 2. So 2 root 5 units. This is going to be the distance between the point A and B. Let me consider the second question. Minus 3, 7, 2 and 2, 4, minus 1. Again, you can take the points to be A and B. Let A be x1 comma y1 comma z1. Let B be x2 comma y2 comma z2. You can take A as minus 3 comma 7 comma 2, and you can take your B as 4 comma 2 comma 4 comma minus 1. You can use the same distance formula to find out the distance between the 2 points AB. Here I am not going to repeat the formula, rather I am going to write it directly. Okay, so I can take x1 x2 minus x1. This will be 2 minus of minus 3 whole square plus 4 minus 7 whole square plus minus 1 minus 2 whole square. Upon solving, I will be getting under the root 2 minus of minus is plus 2 plus 3, which is going to be 5. So it is going to be 5 square plus minus 3 whole square, again minus 3 whole square. AB is going to be equal to under the root 5 square is 25 minus 3 square is 9. Again the minus 3 square is 9. AB is going to be equal to 25 plus 9 which is 18. So AB can be written as root of 43. Since 43 is a prime number, I can leave it as it is. So it is going to be AB, which is root 43 units. I hope this problem is clear. Next concept is collinear points in three dimensions. What are collinear points? If two or more points lie on a same line, then those points are called collinear points. Here A, B and C are collinear points as they lie on the same line. If three points A, B and C are collinear, then I can tell that the length AC is going to be equal to the length AB plus the length BC. So this is the concept which we are going to use in the exercise problems. Second question. Show that the points minus 2 comma 3 comma 5, 1 comma 2 comma 3 and 7 comma 0 comma minus 1 are collinear. So I will be starting by taking these points as A, B and C respectively. You can consider your A as x1, y1 and z1. You can take your B, or rather let me note down the coordinates first, right? So let me take the point A to be minus 2 comma 3 comma 5. Let me take the point B to be 1 comma 2 comma 3. Let me take the point C to be 7 comma 0 comma minus 1. Right? Now I have to prove that AB any one of the line. If I take AC, then that should be equal to AB plus BC. Right? The distance of 2 points, when you add the sum of the distance of 2 points, should be equal to the distance between the other 2 points. To do that, I have to calculate the distance AB, BC and also AC, right? Let me do that. So AB distance, if I have to calculate, then it is going to be x2 minus x1 plus y2 minus y1 plus z2 minus z1. I am going to do it directly. Okay, minus 2 minus 1. So I can write minus 2 minus 1 whole square plus 3 minus 2 whole square plus 5 minus 3 whole square. Solving, I will be getting AB under the root minus into minus is plus minus 3 whole square plus 3 minus 2 is 1 square plus 5 minus 3 is 2 square. AB is going to be root of minus 3 square is 9 plus 1 square is 1, 2 square is 4. I will be getting AB which is equal to root of 14. So I can take this as 14 units. This is your equation number 1. Next, you can consider the distance BC. If I consider the distance B and C, I can write x2 minus x1, which is 7 minus 1 whole square, plus y2 minus y1, 0 minus 2 whole square, plus minus 1 minus 3 minus 1 minus 3 whole square. BC is going to be under the root. 7 minus 1 is 6, so 6 square, plus 0 minus 2 whole square, minus 1 minus 3 minus 4 whole square. Upon solving, I will be getting root of 6 square is 36, minus 2 square is 4, 4 square is 16. The answer is going to be 36 plus 20. I will be getting the answer as root 56 units. Root 56 units. Can I simplify 56? 56 I can divide with 2. I will be getting 28. Again you can divide by 2. You are going to get 14. 14 can be divided by 7 as 2 and 2 as 1. So I can write this as there is one pair. So 2 root 7 and 2 are lone pairs. So 7 multiplied by 2, which is 14. You can write your BC as 2 root 14 units. This will be your equation number 2. Next, I should be taking A and C. So AC can be also found out. Let me write it here. AC is going to be again 7 minus of minus 2. So I can write 7 minus of minus 2 whole square, plus y2 minus y1, 0 minus 3 whole square, plus z2 minus z1, minus 1 minus 5, minus 1 minus 5 whole square, minus 5 whole square. AC is going to be equal to 7 minus of minus, it is plus 7 plus 2 is 9, 9 square, plus 0 minus 3 is minus 3 whole square, plus minus 1 minus 5 is minus 6 whole square. AC is going to be equal to 9 square, which is 81, plus 3 square, which is 9, plus 30 minus 6 square, which is 36. So AC can be written as 81 plus 9, which is 90. 90 plus 36, it is root of 126. I can write 126 as, if you divide with 2, you will be getting 61. Anything else? Can you do anything else over here? Anything else? Sorry, this is 3. This is not 1. 2 divides 12 by 6. 6 by 3. 3 again you can divide with 7. 7 9 times. Again 3 3 times. 3 1 time. So we have a pair of 3 and we have lone pair 2 and 7. I can write AC as 3 root 2 multiplied by 7, which is 14 units. This can be your equation number 3. Now you can end the question by saying, let me just take one more slide over here. We have got 1, 2 and 3 equation. Also the distances, which is AB, I have got as root 14 units. If I am not wrong, AB is root 14 units. Equation number 2 is BC, which is 2 root 14 units, and AC I have got as 3 root 14 units. from 1, 2, and 3. Now, can I tell here that AC is equal to AB plus BC? AC is 3 root 3, 3 root 14. Is it equal to AB, which is root 14, can be written as 1 root 14 plus 2 root 14. Hence, proved that A, B, and C are collinear points. I hope this question is clear.